A couple of years ago, we launched a new service called the Quasar Pulse, which is a base service comprising gamma ray, directional, PWD, and vibration measurements. That provides some of the essential basics that are needed for drilling wells in very high temperatures. That system is designed to go up to 200 degrees Celsius. On top of that, we've added the Quasar Trio, and what that brings is additional measurements, resistivity, density, and neutron porosity. Now, the key thing to know about those is that they're essential measurements for evaluating high-temperature wells, specifically gas reservoirs. Many high-temperature reservoirs are gas-bearing, and in order to properly evaluate gas-bearing zones, you need to have all of those measurements. We have one operator in particular who's been using the system quite a bit in the Far East. In that case, they've got a situation where they're developing a gas field. They are the business model that drives them is dependent upon being able to get the wells drilled quickly and completed quickly and getting them on production quickly. So anything we can do to save them time in that process is valuable to them. So, of course, running the Quasar Trio gives them the opportunity to eliminate most of their wireline logging runs, and it saves time on the rig, and thereby saves them a lot of money. So now the Quasar Trio has become pretty much a standard for most of their reservoir sections that they've been drilling. The primary differentiator is in the electronics. A lot of engineering work has gone into the electronic systems that run the tool to allow them to run at the high temperatures. Traditional electronics are good for about 175 degrees Celsius. We spent a lot of effort trying to get the temperature spec up to 200 degrees through various measures based on design, component selection, testing, screening, all those kinds of things. And the result is a tool that is stable and works well at 200 degrees C, which is a significant achievement, particularly for some measurements like the density, which is sensitive to changes in temperature, and being able to achieve a stable density measurement at those high temperatures was very challenging. But we've managed to do it and produce a tool that produces measurements which are as good as the legacy tools that we have. And what we've ended up with is the first system in the industry that allows operators to capture triple combo data with LWD at 200 degrees Celsius.